deep-sea podcast, Pressurised, a short, punchy version of our main feed that gets right to the scientific point. If you like what you hear, you'd like to hear the full episode, you can find it in the same feed. And now, to get right to the point.
So the Twilight Zone, top 1,000 metres, which is also in the benthic part of the Twilight Zone, is where you'd find some features upon the continental shelf. Now, Tom, let's start thinking about what features are there within the continental shelf.
Well, surely it's just a big old boring shelf and it's all flat. Surely there's not big interesting cracks in it that are quite often associated with a big river on land. So it's almost like the river continues into the deep sea and carves these beautiful paths that really mix up the habitat.
But if there was, we would have spoke about that when we did that whole arc about all the different types of deep-sea habitats. So surely it must be one of them. Or...
Well, either they've just been discovered this last month, or people are really busy and they can't always talk to... Like, we pick a theme, but it doesn't mean that people are available to talk during that theme. Turns out scientists are busy and go away a lot.
Yeah. Let's talk about submarine canyons.
I'm joined by Teresa Amaro, a deep-sea ecologist currently based at the Department of Biology at the University of Aveiro. Her research interests cover trophic ecology of different deep-sea ecosystems, and that includes, and what we're going to focus on today, is submarine canyons, but you also dabble in abyssal plains and seamounts and contrasting ocean basins. Thanks for coming to have a chat with us.
Thank you for inviting me.
We've been trying to cover the different deep-sea habitats because there's the idea that the deep sea is just this big open space that's pretty boring. And to be fair, a lot of the abyssal plain is, but there's a few key habitats in there. So I wanted to start by putting canyons into context. So we have like the continental slope where the land transitions into the abyssal plain. So we have this long slope. But what specifically is a canyon? What sets it apart from the more regular slope?
I normally, whenever I talk to people, I normally tell them to spot the Grand Canyon in the US and then put that image in underwater. And I think then people will understand. And I think it's a very good description of what a canyon might look like.
Yeah, it's an easily accessible one.
Yeah.
Are they, I mean, like the Grand Canyon, do they tend to be associated with rivers?
Yes. Although one of my favorite canyon, the Nazaré Canyon, is not.
Oh.
So in Portugal, for instance, you have the Lisbon Canyon and the Setúbal Canyon, and they are associated with rivers. But the Nazaré Canyon, which is a little bit north of Lisbon, is not. So you can have both type of canyons.
And is the river-based ones the most common type?
I think it is because, as you can imagine, you have like a very big influence of a river and the currents, and then along the time, this can be transformed into a canyon. But, for instance, you have the withut Canyon that is not associated with lands. It's not associated with a river. And it's like in the middle of the ocean. And then all of a sudden you have a canyon. So it has been in the past, but then it's not anymore.
Oh, okay.
But the Nazaré Canyon is like a huge cliff. And sometimes the canyon, takes some kilometers to actually really start. But you have then some canyons like Nazaré Canyon that starts immediately at 0 meters. So if you see it from land, you see a huge cliff. And then, it starts immediately from, like I say, from 0 to 6,000 meters depth.
Wow. And that must really give different properties, because if they're sort of created by a river, if they're almost an extension of an estuary, there's lots of material coming in from the land as well. Yeah. And it's sort of quite a slope. And then it sounds like there's another type of canyons that used to be formed from rivers or maybe formed just as clefts in the Earth's crust. And they must have really different properties.
Yes, but for instance, Nazaré Canyon, you have a deposition of organic matter, so this material. And if you studied those walls and the terrains that you have there, it's actually, the material is really rich with the terrestrial input. So it's absolutely right what you say. But in the Nazaré Canyon, you also find these things. And I think at the moment I cannot really compare, for instance, between the Nazaré Canyon and the Lisbon Canyon or the Setúbal, which has river input. But I think the Nazaré Canyon in terms of organic matter is enriched, and it's fresher than the Lisbon Canyon, for instance, where you have a river. So the reason for that, I don't know. I think it's also, it has to be with the currents And it has to be with the oceanographic features, that you have in there. But especially that canyon, which is the canyon that I actually know the most, the organic material is really enriched and until very deep.
Which makes sense why it's a good place to live.
Yeah. Yeah.
We'll get on to the animals in a second. Is there actually a definition of a canyon? Because, of course, the seabed's pretty varied. Is there a point where a cleft or a crack in the Earth's crust becomes a canyon?
Yeah, I think you can define as submarine canyons are deep, large-scale incisions that can occur on the continental shelf. Yeah, and I think they can exist in all ocean margins. And these landforms, serve as a preferential particle transport conduits, of organic material that can connect then the coast with the deep sea.
So we know that the abyssal plains on the whole are a very static and low energy environment. And that's why this input will be incredibly important. So what are the ways, other than having more organic material in them, what are other ways that the canyons differ from the open plains that surround them?
I know that abyssal plains normally, they are not rich in organic matter and they are really dependent on what's happening in the shallow water, like the spring blooms, for instance, and then they are completely dependent on the degradation of organic matter that falls from shallow water all the way to the abyssal plain. Whereas canyons, if there is a transport of something that comes from lands, then it helps, the formation of the canyon, it really helps to transport the material into the deep sea. So if you see the structure, it's like a river, right? And then it helps to transport these material to the deep sea, and then of course it helps to feed the animals or the organisms that exist there.
And sometimes there can be quite dramatic sediment flows, so it's almost too much of a good thing for the animals that live there. There are these huge turbidity events which are like a mudslide down the canyons.
Exactly.
There's also some unusual currents that take place around canyons. I forget where I was. It was somewhere in the Bay of Biscay, I think it was, but there's flushing events where there'll be a huge movement of water mass, not just the sediment moving down, but actually some of the strongest currents we've measured, aren't they?
Yeah, I imagine like a snowball, that comes all the way, from the canyon, then it decreases, in volume, and then it just goes down until it finds a terrain. But yes, and also then if you have these turbidity events, then they are actually perfect for the fauna there. Well, sometimes.
As long as they're not too close.
Yeah, as you can imagine, if like the snowball or these turbidity events, if they are like too strong, they can damage all those animals, that are living on top.
Or smother if they're fixed.
Yeah, exactly. And then it will be very bad for them. But then it will help others afterwards.
Yeah. Do they have much in common with the Hadal trenches? A lot of this is similar. It's another abyssal adjacent habitat whereas the abyssal zone is quite static and you end up with long-lived animals that eke by on very little food. And then you have this dynamic environment next to it where there is an abundance of food. So the animals tend to have a higher generation time because every now and then there'll be a catastrophic event that'll wipe out a large part of their population, so they reproduce more quickly to bounce back after one of those events. Is there a similar thing there?
Yeah, exactly like that. Yes. I don't know much about trenches, but I can imagine that in a trench, whenever you have these events, it drags all the food down, right? And then in canyons, I think the steep of these slopes can be a bit less than trenches. But then if you imagine a river, right, underwater and with a slight inclination, which keeps the material being dragged and until it finds a terrain when can be deposit. You really have to imagine like a river going, slowly, most of the times, going down. Whereas what I see on a trench, and I might be wrong, I think that it can be steeper so that the material can be deposited quicker, I think.
Yeah, they tend to be in the abyssal plains, and so they don't have that direct flow, like if there's a river. So there's there's not material coming from one end, but it does act like a funnel, and then every now and then we get the seismic events, so a tremor that will almost shake all the material into the trench. So it ends up enriched next to the abyssal zones next to it, which are more sort of food impoverished. So maybe similar to the trenches, then this is quite a different environment than either of the adjacent ones, than that of the continental slope or the abyssal plains. Are there canyon specialist species? Are there species that really thrive there and that are maybe only found in canyons?
Yeah, there are a lot of endemic species. But as you know, by being a deep sea researcher, you know that we also do not know a lot about the deep sea. And we are still finding more and more deep sea fauna, let's say. So yes, I would call it that there are special organisms living there. But I also tend to, although I know that in lots of papers it's written that they are endemic, for instance, but I tend to also to think that because we don't know a lot about the deep sea, I'm not so sure if we would find these fauna, for instance, elsewhere.
No, definitely. We have a tendency within the deep sea community, at least, to have a lot of biodiversity hotspots and a lot of endemism that really might just be, well, we've only got one sample. So by definition, it's a hotspot and an endemic species.
Yeah.
Without sort of saying that they have to live in the canyons, what sort of animals do you find there in abundance? What are doing particularly well in them?
So, for instance, deep sea cucumbers, holothurians, they live great in a canyon. They are like the first ones to appear whenever there is a organic matter event, deposition event. And they act like they are vacuum cleaners, they just wipe out all the fresh organic matter. And then it gives space to the other fauna to interact. So, for instance, holothurians in abyssal plain, they are not there. And suddenly they appear.
They've been hiding somewhere.
Yeah, we still don't understand from where they are coming from. I give you like 2 examples. So if you go to the Nazaré Canyon, 3,500 meters, you see a very high deposition of holothurians there. And then I studied the place, and it's, at that time, the material was fresh, and I could really prove, that the holothurians at that time, they were feeding from fresh organic matter. Whereas if you go to the withut Canyon, I visit the place several times along different depths, and I found out that suddenly the holothurians were there. And then you go if you go shallower or deeper, they were not there anymore. And so I was like, wow, why? Is it because it's like the perfect place to have a deposit, of organic matter or not? I don't know. And then these holothurians, I immediately start thinking, how come, what do they eat? And then I hypothesized that whenever the fresh material is there, they prefer, this fresh organic material. And I could really see, because I look into the guts, I could really see that these holothurians were eating fresh material, and this fresh material being degraded along the gut. And also in the Nazaré Canyon, I look at the feces content, and I could really, connect, the degradation of fresh degraded material. But then you also see that whenever holothurians do not have fresh material, they can also survive with very old material, so coming from, for instance, bacteria. So I cannot understand, if I put it that way, how they survive and why you have nothing there and suddenly it appears.
How are so many ready? Where are they when they're not there?
Yeah.
Is this a swimming species?
So in the Nazaré Canyon, they were not. So they were living under the sediment, whereas the species that I found, the holothurians that I found in the withut, they were swimming. Yeah. And then I found out by a paper with Fabio De Leo that you have the same species in the canyon you have in New Zealand, the Kaikoura Canyon.
Oh.
So there is a very big similarity in terms of these holothurians and these canyons, although the canyons are totally different, but the species is the same. So they live under the sediments. one of the questions that I really wanted to look at was actually to go to New Zealand and have a look at the Kaikoura Canyon and to see how different or how similar it is from the Nazaré Canyon, because the Holothurians are there, it's the same species, but I never had the chance to look at the organic matter from the Kaikoura Canyon.
We should keep in touch. I might be able to help with that.
Yes, please. Definitely. Because, for instance, in the Nazaré Canyon, I really wanted to have the feces intact because, so you had the Holothurian, you had the gut. So I collected the sediment and then I collected the Holothurian. And so I dissect the gut, and then I look at the organic material in the beginning, middle, and the end. And then I had to have the feces intact. So together with Ben Burman that worked at the NOC.
Oh, yeah.
We built a poo collector, which was like really great. So I said to Ben that I really needed to have a device that would allow me to collect poo from the Holothurians, because to collect the poo straight from the sediment, it would have been contaminated, by the sediment. So we created a poo collector. So we put Holothurians, we had little devices, and then with an ROV, we put the Holothurians in each plate. We let it be for 3 to 4 days. So each Holothurian had like a kind of a funnel. And then whenever they would release the poo, it would fall into a vial. And then whenever we arrived there to collect the device, we just shut the vial so it could not be, contaminated.
So part sediment trap, part music festival toilet.
Yeah, exactly. But it was a sediment trap with only Holothurian poo. You know what I mean? So, but yes, it's the same effect. And then it was really nice because you could see that the Holothurian, the gut, was completely empty.
You knew you had it.
Yeah, my objective was perfectly fulfilled. I managed to collect the feces, and then I had a perfect connection. I had the sediment, I had the Holothurian gut, and then the feces. So I could perfectly study which kind of material these Holothurians were eating, and if there would be a degradation along the gut.
So these are detritivores. They're living on the soft sediment at the bottom that is sort of cascading down.
Yeah.
There's going to be rocky sides as well, though. What are sort of the animals we find there? We find filter feeders there.
Like corals. And although I've never had a chance to study them in the deep sea, sponges, of course, they exist there as well. But for instance, in the abyssal plain, and now relating to the research I'm doing at the moment, they exist in there, in the abyssal plain, but I've never had a chance to study them.
So there's multiple environments there. There's these rocky sides and then the sediment at the bottom, but it's a really complex environment. There's a lot of dynamic things going on. How do you sample here? Because this is tricky. This is not a place you could easily tow gear.
Yeah. So it depends how close the walls are from each other. Yes, you can go there with the ROV, of course, and try to collect some animals. It depends on the walls and if it allows you. I'm remembering now that we actually deployed a lander in the Nazaré Canyon, and by the time we went there, to retrieve it, the lander never came back. Yeah, it's really hard. So I think you first have to study in detail how the canyon is, the morphology, and see where you can go with your gear, either with a lander, either with a sediment trap, or with an ROV.
I accidentally did a transect with a lander. I think it might have been.
Wow!
It's probably one of the canyons you mentioned. It was one in the Bay of Biscay. The names escape me now. But yeah, it was during one of these flushing events, and I was measuring over 40 centimeters per second flow, and the lander was just being pushed along the seabed. And usually we've got loads of ballast and they hardly move.
Wow!
And this was real force. It traveled a long way.
But you managed to retrieve it, right?
Yeah, and then I got this amazing transect as my lander was like bashed along with the current.
Wow, that's cool. I think it was a cruise with Alan in the Nazaré Canyon. very early beginning, where I think he was doing some research together with Rachel Jeffries.
Oh, yes. Yeah, that was in the early days of Ocean Lab.
Yeah. And the lander never came up. So the experiment from Rachel, the lander never came up, and along with her samples. So it was kind of sad, of course.
It happens from time to time.
Yeah, I know. I know that.
Everything you put in the sea is temporary.
Yeah.
It's only on loan. Every time you get it back, you're lucky.
Yeah, exactly. Yeah.
What do you think are the big questions that still lay ahead? What are the big questions in canyon research?
I think they're still the same, aren't they? Like, we find out lots of things. We discovered lots of new things. We discovered there are really hotspots of biodiversity. But I think the questions are still there. How come the species or the organisms survive? How come these turbidity events happen? Like, you can imagine why, or all of a sudden you have a snowball, dragging all the material down, and you can imagine these events to happen, but not to the turbidity, right? How? Why?
Yeah.
And how come these fauna survive? Like these things that I told you about the holothurians. Suddenly, you go there and then they are not there. And if you only have one shot, and then you'd say, oh, canyons, they don't have anything, in terms, for instance, of sea cucumbers. And then if it happens that you go there again, and then you find like high densities of these, then you change your hypothesis. So this to tell you that because canyon research is very expensive, and if you have only one shot or two, you might conclude something, but then if you keep on going there, maybe, you conclude something else.
Yeah, we assume the snapshot that we get is accurate, but
yeah,
if you'd only gone to that canyon once, depending on when you go, it's either teeming with holothurians or it's empty.
Exactly. No, it's true. So I think there are a lot of questions. I think our questions, hypotheses that we have in canyons, I think they still exist because thanks to this European project, and I'm talking about the project that I was in, Hermes and the Hermione, we kind of covered a lot of research in canyons, but it was really, I think, the beginning. And then all of a sudden, I think you have still some people that manage to have canyon research, but then suddenly we have to move on. Like me, for instance, I love canyons, and if I could, I would immediately change my research back to canyons. But then, my research funds, are not there anymore.
Yeah, you can only lose so many landers before you run out of money.
Yeah,
that's what we found.
Yeah, exactly. So I think the questions are still there, aren't they?
I agree. Still lots to do.
Multidisciplinary research on canyons again. And what I learned, it's not nice to only focus on biology. So you have to have a very multidisciplinary research, and you have to go on a multidisciplinary cruise actually to kind of understand what's going on there. So I learned that with all my cruises, and I was really lucky to have the geologists there. I learned a lot from the geologists, and they were always the first ones, to go in, and then we biologists would go there. So I tend to say that I'm not a biologist anymore. Because I try to answer my questions based, on a multidisciplinary context.
Nothing exists in a vacuum. They all inform each other.
Yeah. So you have to do it in a multidisciplinary way, I think. So that's what I learned. And ever since, I've been trying to focus my research in this matter. If for instance, I'm leading a project now, it's not deep sea, unfortunately. But it's coastal, and we managed to write it, and I try to invite people from all the disciplines, because I don't think you can answer your question, even though it's very ecological, cannot only have the biologists. So you have to have all disciplines with you. Yeah. So that's what I learned thanks to canyons.
It's difficult it makes it such a difficult project to sort of fund, and there's lots of moving parts to it. But But yeah, so often your biological context is answered by the geologists. You know, you're wondering like, well, why is this here? Why wasn't it over there? And then they'll just chime in with, well, this one's really old and that one hasn't existed long enough. And then that's it. That's the biological answer is answered by the geology.
And chemistry, because to analyze how old the organic material is, and you can use isotopes or fatty acids. And so I tend to say that now I'm a biochemistry ecologist. I wasn't there to say geo, but I need a geologist with me all the time, I think.
Everybody does. They need a geologist friend.
Yes, totally right.
Thank you so much, Teresa. Thanks for having a chat.
Yeah, no problem. It was a pleasure.
And that was a pressurized version of one of our longer episodes. If you enjoyed that and you would like to hear the full-length episode, just match the episode numbers and you'll be able to find the full-length version in the feed. Thanks for listening. We'll deep see you next time, and I abyss you already.